All right, moving on in trig. So we got more identities now. So there's three different types that we're going to look at over the next couple of lessons. Today's lesson, we'll just look at double angle and power reducing, and then on the next day we're in here, we'll look at half angle identity. So double angle, I'm going to give you the identity, then I'm going to show you where it comes from. So the first double angle identity is this. It says sine of 2 theta is 2 sine theta cosine theta. So it just means that the angle on the left is double the angle on the right. This 2 is always here. So no matter what this angle is, the angle on the left is double the angle on the right. So just a couple of examples of what I could write here. What this means like the sine of 60 degrees should be 2 times the sine of 30 cosine of 30. Because the angle on the left is double the angle on the right. Or I could say sine of 4x is 2 sine 2x cosine 2x. I just want to make sure that you understand what the identity represents. Okay? Okay, and now what I'll show you is I'll show you where this comes from. Okay, so on all these identities, we will derive it. So where does this first one come from? Well, if you take your, go back to your sum and difference, and we take the sum identity for sine, so sine of alpha plus beta, sine alpha cosine beta plus cosine alpha sine beta. Okay? You got that identity. If we take this and we replace alpha and beta both with theta, then we'll have 2 thetas in there. See, so how do I get 2 thetas? Well, I'm going to add 2 thetas together. Theta and a theta is 2 theta. So what I'm going to do to derive this, I'll make alpha theta and I'll make beta theta. So there's my sine of 2 theta, and everywhere I see an alpha or a beta, I'll put theta. So I get sine theta cosine theta plus cosine theta sine theta. It's a 2-second derivation. That's why we're right here. We're almost done. Now, maybe you don't recognize it, but those are the same term. This is sine theta, cosine theta. This is the same thing. I'm just going to change the order. So sine theta times cosine theta plus this is sine theta times cosine theta. And so add those together. I have 2 sine theta. That's sine of 2 theta. That's where it comes from. And they all are that way. Okay? So we'll derive there's actually 3 main, there's one for sine, one for cosine, one for tangent. Cosine can be written a couple of different ways, I'll show you that. So let's go ahead and derive cosine and tangent. So how do I get cosines? We'll save that one. Cosine of alpha plus beta goes, so how does that go? What's that identity? You may have to look it up, right? I doubt we have it memorized. Very good. So what are you going to do? If you want to get cosine of 2 theta, you're going to take and make alpha and beta both what? Theta. Theta plus theta. And wherever you see an alpha, you're going to put what? Theta, and beta, you put theta. That's how you derive it. You want 2 theta, you add 2 thetas together. Okay? So then you shove it in and simplify this as much as you can. There's really not much you can do. There's only a 1-step problem. Okay, so what happens? You get cosine theta times cosine theta minus sine theta times sine theta. Well, what's cosine theta times cosine theta? No, not 2 cosine theta, it's multiplication. It's cosine squared theta minus sine squared theta. And there's that one. So we've got cosine of 2 theta is 2 sine theta cosine theta. We've got cosine of 2 theta is cosine squared minus sine squared. That's similar to what identity? What identity has squares? Yeah, Pythagorean. It's similar. Not the same though. Okay? We'll test these out in a second. It's just better first if we just derive them. So I'm running out of room, of course. So here's what I'm going to do. Let me erase these couple of examples. I'm going to put 2 equals sign for cosine because we write it 2 other ways. So we'll do that at the end, and then let's get tangent. Okay? So again, we need our room here for scratch work. If we're going to get tangent, we're going to use the tangent of alpha plus beta. So we use the sum identity for tangent. Tangent of alpha plus beta is what? What's that identity? All right, very good. So now if we want tangent of alpha plus beta, in place of alpha and beta, we need to put what? Theta. So you would do theta plus theta. And everywhere you see it, alpha, you put theta. Everywhere you see it, beta. Remember, if you add 2 things, right, then you put a 2 in front. If you multiply, it's a square. Okay, that's it. And again, it's only one step. Plug your theta in and do whatever adding or multiplying you can do, and that's it. You guys think you're gonna play today?
Yes.
Because you have infield as turf, right?
Yes. I feel like our JV might not play today, but I feel like we will.
Yeah, we play tomorrow. Okay, so it's tan theta plus tan theta over 1 minus tangent theta times tangent. Okay, so the numerator becomes what? Yeah, 2 tan theta. The denominator is 1 minus tangent squared theta. That's it. That's your double angle identity for tangent. 2 tan theta over 1 minus tangent squared theta. All right. Now, there are 5 of these. So double angle identities, there's 5. Obviously, we have 3. So before we start looking at using them, we'll just save that there again. People at home, if you got the video, you can pause it. All right. So what are the other 2 cosine? So basically, here's what we're going to do. Since we have Pythagorean identities, over on the Pythagorean, each of these can be written in terms of the other one. So what I mean by that is, from our Pythagorean, we know, that's an O, that cosine squared theta is 1 minus sine squared theta, and we know sine squared theta is 1 minus cosine squared theta. So what I'm going to do is say, for instance, I'll start here with cosine. I'm going to take it out and put in 1 minus sine squared so that the whole right-hand side is just either a sines or a cosines. It's just another way to write it. Okay, so for instance, we'll take this first one. So here's our first double angle identity. And in place of cosine squared, I'm going to use my Pythagorean identity, and I know that cosine squared is 1 minus sine squared. So all I've done is made that replacement. So now my double angle identity for cosine is just has sine in it. Okay, and this has a use later on. So since I have 1 minus sine squared, that becomes 1 minus 2 sine squared theta. And that's the second double angle identity for cosine. All right. Now I go back to the main identity for cosine. And in place of sine squared, I'll put what sine squared equals. 1 minus, and now it allows me to have an identity that is just with cosine and cosine squared. So take a second and see how well you can simplify that, okay? Maybe distribute the negative, combine like terms if you can, go from there, see if you can finish that simplification. There's our 5 double angle identities, and then we'll work a couple of sample problems. So, this is how we get cosine squared minus 1 plus cosine squared. Well, cosine squared and cosine squared, we get 2 cosine squared minus 1. That's our last identity. These are your 5 double angle identities. Okay. So, I can tell you this. I know this is going to sound like all these problems we're going to work, that's not minus a negative is a plus, cosine squared. Okay. All these little problems we're going to work, that's not what I ever use them for. I always use these in calculus. And it's like subtle, like, so for instance, in calculus, we do something called integrals. And you might get a problem like this in calculus. You're like, oh my God. That's like, you cannot work, you can't do what it wants you to do. It wants you to find what's called the antiderivative. You can't work it like that. You're like, oh, I have no idea. All right, that's a very different, that's a no way to work it problem. But if you recognize that this is the right-hand side of this, so this is basically, it's a simplification. You're going from 2 squares to no squares to just a 2 theta on the inside, or basically a 2x. If you go and write it like this, now in the realm of calculus, it goes to easy. So you go from impossible, virtually impossible, there's no rule for it, to an easy problem. That's what I always use these identities for. Not these little rinky-dink questions that we're about to answer, but it's what is part of trig. So for me, it was making replacements. Okay. Sound like rain. All right. So you can't, like, it's one of these, you can't really appreciate it. Here's all I can tell you. Who all's planning on, well, I know all of you are going to college. Who's going into maybe engineering or science or computer science realm? One? Whatever you do, you ever seen Waterboy? You know the little notebook? That's what that is. Don't lose it. Yes, the whole thing, all the notes I've given you. You're gonna walk around with it like that other coach, right? The mean guy. And hold on to it. Because this will come in, it'll be helpful, okay? All right. Or you got all the videos now on YouTube, so I don't even know why I'm teaching anymore. Just use the videos. Get rid of me, right? Okay. All right, so I guess I'm just going to erase these now. You have them, and then we'll just refer to them. So what kind of question? So we'll look at example one. Notice we don't know anything about. Before we do example one, let's just make sure that this is. Let's see if this is legit. Like let's do the sine one real quick. So sine. Before I do this, sine 2 theta is 2 sine theta cosine theta. Let's check it out. Let's take a 30, 60, 90. And the reason a 30, 60, 90 comes to mind is because 60 is double 30. And if we look at the sides, right? So according to this identity, sine of what should equal 2 sine of what cosine of what? Yeah, well, what's 2 times 30? 60, thank you. Sine of 60 should equal 2. All right, well, let's check it out. So plug in your sine 30, plug in your cosine 30, multiply by 2, see if it's sine of 60. Let's just see if it actually works first before we start jumping in. So numerically, it should work that way once you plug in your ratio. All right, so let's see. Our calculator is getting out. Why would you get out a calculator? You don't need a calculator. Just do it. Like you don't want to plug this in on your calculator. Just do your fractions. What's sine of 30? 1/2. What's cosine of 30? This is why you don't remember anything, because you use those. You got to get out of that habit. So it's sine of 60 squared 3 over 2. Yeah. Right. Yeah, don't type it in. Okay. So we just want to check that out. So here's what we're being asked to find. We're given sine of theta. We're given that it's in quadrant 2. Can we find these three? So now it's very similar to what we've been doing with, we're going to use the triangles and we're going to use our identities. I'm going to go ahead and erase this. This was just to show you. Yes, sine of 60 is square root of 3 over 2. All right, so let's start with this sine of 2 theta identity. So here's what we're given. We're told sine of theta is 5/13, so we're told theta is in quadrant 2. If we want to get sine of 2 theta, so this is example 1a, we need sine theta and we need cosine theta. So sine theta we're given. How do we figure out cosine theta? So you're going to see this is just a bunch of just write your identity out, plug in what you need in order to, because I want to find this. So I need to figure out what sine, I know sine theta, and then I need to figure out cosine theta. Once you plug those in and do the work, you'll have the answer, okay? So question, how do I get cosine theta?
It's in quadrant 2, you create a triangle and it'd be negative 12 and 13.
This is exactly what you do. So you're back to drawing triangles like we did in the last section. Very similar to what you did on some of the problems in the last section. So you just got, so it tells you theta is in quadrant 2. So we're going to draw the triangle in quadrant 2 with everything you said was correct. We know sine is 5/13. We'll then find the adjacent, which is 12, but it needs to be negative because we're in quadrant 2. That's huge. And now you know that, and that's just angle theta. So now you know cosine of theta is negative 12/13. And now you just plug in. There's your cosine. There's your sine. All right. Real quick, I don't need it on this problem, but well, actually, yeah, you don't need it at all. So why don't you do this? Plug into the right-hand side, simplify, get your answer. When you do part B, cosine of 2 theta, you have choices. Use whichever one you want. I typically just use the first one, cosine squared minus sine squared. And then when I get to part C, I'm not going to use the identity. I'm not going to use that identity. What am I going to do to get tangent of 2 theta on part C? Yeah, do sine over cosine. Hopefully I got these right. If you mess these up, then that's probably gonna be wrong. But that's what I would do. So why don't you try that? Plug in your information. All right, now remember cosine squared means plug in your cosine ratio and then square it, okay? Same for sine squared. Plug in your sine ratio and then square it. So take a second and see if you can work this out, and then we'll check our answers. And I'm gonna go ahead and put an example two up here. A couple of problems.
You have to do it on twice.
Can you come?
Yeah, I won't.
Yeah, sorry.
No, you're fine.
All right, let's check the first one. So if we plug in 5/13, -12/13, let's see what we get. So this now is just a practice of multiplying fractions. So what does your numerator turn into? What's that? You gotta get numerator and denominator.
Oh, sorry, I was on
Yeah. Numerator. -120, and then over 169, and there you go. Done. All right, now we do cosine squared. So we plug in our cosine, so -12/13, and we square, minus our sine 5/13, and we square. So let's see, 12/13 squared, what does that become? Yeah, and 5/13 squared, what's that? And if you add your numerator or subtract your numerators, you got what? 119 over 169. Now, you should know what quadrant this is in. Sine is negative, cosine is positive. There you go. And then I would just do this. I wouldn't use the tangent identity because I have sine or cosine. I feel pretty good about our work, right? So then I would just sub those in. Sine is -120 over 169. Cosine is 119 over 169. So you divide by a fraction, what should you do? Yeah, so you get 120 over 169, 119. Cancel, you get -120 over 119. So Is that true in the fourth quadrant? Is tangent negative? Yeah. Okay, so there you go. All right. So this is the idea of, like, on this type, like, you may have to draw the triangle to help you. Now, the second one, you don't need triangles. Now, so I know it's down there, it's kind of low, but that says 2 sine 22.5 cosine 22.5. So the first thing you've got to think when you get a problem is, can I find the sine of 22.5 degrees? Or what's the answer? Without a calculator, what's the answer to that? Sine of 22.5, does that ring a bell? No. So you know that you're not going to actually evaluate that one. So, all right, let me erase our scratch work here and we'll get this. So I would have my identities in front of me and try to match it. So the whole idea is that there should be a way to rewrite it. Okay, and then in that way that we rewrite it, it should be easier to work. So if we go 2 sine 22.5 cosine 22.5. Well, I can't do either one of those. Now, but I see it goes 2 sine cosine. So it's obviously the what side of our identity. Right, so what you're going to do is now what we want you to understand is that these identities work both ways. You don't always go left to right, you may go right to left. So by going right to left, you can now just write it as sine of something, and you got to figure out what that angle is, and that should be an angle you can work with. That's how you're going to work these. So the question is, sine of what angle needs to be here if these are 22.5? Well, what's the answer to that? 45. This is why it's called double angle identity. The angle on the left is double the angle on the right. Okay, so there you go. Then you make it sine 45. So let's see what it says. Write each expression as the sine, cosine, or tangent of a double angle and find the exact value. Now, you'll just work this out by hand. You use your special triangle. Okay? That's how you do all three. Now, this is in radians. That's pi over 8. You guys put that in radians, okay? All right, so take a second and see if you can do these three, and then we'll check our work. And then we'll stop today. All right, and that's it. I'll do, these go together. So we'll wait and do these two on, well, Thursday. And it's not open yet. Okay, thank you.
So whatever she decides y'all gonna get, if you don't have enough arguments.
Thank you so much, appreciate it. Going to that side, see. Okay. So on the first one, sine of 45 degrees, we know it's a 45, 90. You use 1 over square root 2, which is square root 2. So that's the exact value for that expression, which is kind of neat, honestly. So here, I say it goes cosine squared of an angle minus sine squared of an angle. So that is the right-hand side of which identity? Cosine of 2 theta. So whatever the angle is on the right, it should be double on the left. So this should just equal to the cosine of 210, which is double 105. Well, I need a triangle for that one. I don't have that memorized. So if I want to work this out, I'm just going to do cosine of 210. My triangle should be in which quadrant? 3. That's 210 degrees. What's my reference angle? 30. Opposite? No. No. Negative 1. Adjacent? Negative square root 3. Hypotenuse? 2. All right, and so I just got to find the cosine. So the cosine is adjacent over hypotenuse, so you get negative square root 3 over 2. Okay. So because it's 210, the reference angle and because it's third quadrant, that's why it's negative. Then the last one, this is the right-hand side of tangent. There should be tangent of double whatever the angle is. So I'm just going to do 2 times pi over 8. Well, if I do 2 times pi over 8, that's pi over 4, which is tangent of how many degrees? Tangent of 45, which I already have that. If you're going to memorize some, that's one you should memorize, right? What's the tangent of 45 always? 1. What's the tangent of negative 45? Negative 1. You make one of those sides negative when you drop it to the fourth quadrant. So that's a good one to memorize. Okay? Because that pops up. And that's it. That's the introduction of what we're doing. So as we develop more identities, then we'll do a little bit more with them. But it's pretty much it, these 2 types. Either you're drawing triangles and using those ratios and plugging it in, or you're going right to left, which is, I think, the simpler. Okay? We'll stop there. Just get through tomorrow, and then we'll move on